In this video, we'll look at how you can use Rafay to provision and operate EKS clusters in auto mode. The platform admin configures a template in Rafay, which then is used by the Rafay agent, which has access to the infrastructure's code sitting in the Git repo. And the Rafay agent then connects to the customer's AWS account to create and provision the EKS cluster. And if you look at the template, the spec has a resource template, credentials, infrastructure's code in the Git repo, and a bunch of other aspects such as customization via hooks, schedules, constraints, and allowed overrides. Now let's look at the Rafay agent. Let's go create a new agent and give it a name, in this case, demo agent, and we're going to deploy a Docker deployment type. Download the configuration files and the commands and run this on a suitable instance. In a few seconds, the agent will be downloaded onto Docker and it'll be operational. Let's check its status by typing docker ps -a. So you can see here, it was just installed a few seconds ago. Now let's create a Git repository. This is where the infrastructure's code for our EKS cluster will be available. Let's connect to our Git repo and let's copy our URL for Git. And it's a private Git repo, so we had to provide it with credentials. So we're going to use username and password for now. And now let's very quickly go and check the status of the repository, making sure we can reach it using the credentials we provided. Now let's go to set up credentials, because we'll be connecting to our AWS account with these credentials. So let's give it a name, a new config context, and this is going to give it a name called Rafay credentials. And let's go put in credentials for the Rafay org for the agent to talk to. And we'll also give the endpoint, which in this case is console.rafay.dev. Now we set up our config context, and I already have set up my AWS credentials with two values, my access key ID and secret. So now let's go create our resource templates. As per our architecture, we're going to have two of them. We're going to have one for EKS lifecycle management and one for the Rafay operator. Let's go create our first resource template, which is going to be for our EKS cluster. And let's give it a version. We're going to use OpenTofu as a Terraform as a provider, and we're going to go to our Git repo that we had just configured. And in that, if you notice, we have the infrastructure's code file. Let's put that in there, and then we're going to select an agent which will drive the infrastructure's code. And then we'll also specify credentials, because we'll be connecting to our AWS account to create these resources. Okay, let's save this and continue. Now let's create the second resource. This will be the Rafay operator, the Rafay Kubernetes operator. So again, specify a version, and we'll go back to the repo, And we had specified a particular folder called Rafay import. Let's copy that path. Specify an agent that we had just configured, and the we're going to now dynamically fetch the variables. Now, what happens here is the agent parses the tf-vars file and pulls out all the variables and shows it to the user or the administrator for selection and configuration. Let's give it a few seconds to see what we detect. And as you can see here, there's a bunch of values that have been pulled out of the variables file. So let's, in our case, we only want to select a few of them, not every one of them. And we have made a selection there. And now we go into the Kubernetes provider, and then we're gonna put in some constraints. We don't want the user to change that in this case. So we're going to select not allowed. And this is an EKS cluster. So there's no reason for the user to change that. So we're going to specify it and configure that as not allowed. Similarly, for the project name, we are going to dynamically retrieve that from our the Rafay project in which we're working. So let's use dollar environment dot project, and this will pull the name of the project in which this is operating. Be done automatically on behalf of the user. The third one for the input variables, we are going to specify a particular, we're going to basically say the overrides are not allowed, and then it's going to be, I guess, a hard-coded value called cloud. So, and then finally, let's go pick our config context. And in this case, it was the Rafay credentials. This is to connect us to the Rafay org. So in our template here, we are only allowed to have 3 constraints, which is kind of what will be shown to the user. So now let's move on to the template, and let's move on to the environment template, and let's configure it. Let's create a new template and give it a name. And this template is going to bring in both the resource templates, but let's start with the version number. And we're just giving it a name called EKS cluster with auto mode configuration, just so that it's easy for the user to understand. And we just also providing a logo so that it's easy for the user to relate to it, and then a brief description for the convenience of the user again. And now we're going to start setting up the input variables. And here we are going to ask the user for some input. We're going to give them some options. They can choose between them. And let's see how we can do that. The first one is we're going to basically say auto mode, yes or no. So let's specify that. basically asking true or false, and there's only one value called true that we specified, and we'll map that to a resource template called EKS cluster auto 1. Next, we'll add a second variable. Here, we're going to ask the user for the name of the cluster. Ideally, the user should provide a unique name for the cluster so that there are no collisions in the same AWS account. And once this is created, once the cluster is created with that name, it is not possible to change it. Even though we're using OpenTofu-based infrastructure as code, it's not possible to change it. So we are providing an indication to the user that please provide a name for your cluster and ensure it's unique. And as you can see here, this is mapped to a particular variable, and we're going to put that inside that resource and map to that. And since we'll be deploying the Rafay operator onto this EKS cluster that we'll be provisioning, we'll also specify that for the cluster name. We'll provide that as input again to that variable. So those variables will be populated with whatever input the user provides here. Now we'll go ask for the AWS region um, as one of the selectors, and the user may be given a few options. In this case, the administrator is deciding that they're going to restrict the number of regions the user can select from. So we're going to allow the user to select from US West 2 and US East 1. And if the user does not pick anything, they'll be shown a particular default. And again, we'll have to map that to a particular variable from our variables dot the resource template. And then we have the same region also applying to our Rafay operator. So we're going to specify that there as well. All right. So now we have essentially three inputs that we are going to present the user. Everything else is pretty much going to be, well, actually, it's going to be four. Um, so we also want to allow the user to choose from a particular kind of cluster blueprint, and we'll be allowing them to choose between two of them. There's a minimal blueprint, which will not deploy anything other than the base Rafay operator, and then the default blueprint, which will deploy everything that comes with the Rafay platform. And the default is minimal. Again, we'll go pick this from the Rafay operator variable and specify it here as a selector. Let's just do that by copying the name of the blueprint right here. Okay, at this point, we have 4 variables. Now, we don't want this cluster to be running 24/7. So we're going to specify some controls around it. We're going to force it to be shut down at 9 p.m. So let's set up a schedule. In this case, conveniently called as shutdown at 9. And we will make sure that this happens every day at a particular time zone. We're going to pick Kolkata time zone, and we're going to basically say specify cron for a particular time, in this case, 9 o'clock. So at 9 p.m. every day, this cron will run and it will shut down the cluster. And then we're going to start the cluster all over again at 9 a.m. And the entire goal here is to save money. Imagine if this is a developer testbed, you don't want this to be spinning and wasting cycles um, at a time when the developer is not awake. So again, we're specifying that at 9 o'clock in the morning, it'll automatically get deployed and destroyed at 9 p.m. at night. And there is our schedule. And we have specified our input variables. And let's now make sure that we add the 2 resources that we had. So let's specify the EKS cluster first. And then we're going to add our Rafay operator. And we're going to make sure it's a dependency because it cannot be deployed until there's a cluster that is being provisioned. So as you can see here, the Rafay operator depends on the EKS cluster. And we're going to pick the variables for the blueprint version, and we're always going to force it the default to be the latest, and we are not going to allow the user to pick an older version. The entire goal there is to make sure the blueprint is always the latest and the greatest. Now let's look at what this looks like when the end user attempts to launch the template, the EKS auto mode config cluster. This is kind of what they'll see. They'll see auto mode enabled. They had to provide a cluster name. And as you saw the user configuring all those constraints and input variables, etc., this has been locked down by the admin to only have a few input variables that the user is allowed to specify. So let's go and add one more for now. We're going to allow a certain Kubernetes version. So up to now, the EKS cluster can be born with a certain Kubernetes version, and we're going to allow the user to pick from the list that we provide. Now we're going to allow only specific versions. We're going to allow 1.29, 1.30, and 1.31. Going to give 3 versions as choices for the user with a default of 1.30. And this will map to a certain resource in the resource template. So let's make sure we go and specify that. And let's open the variables file to see which it is going to map to. And it's going to map to the cluster version. All right. So once you kind of reviewed all of this, let's save it. And there's going to be one more variable that is going to be presented to the user as an option. And we had initially asked for the project name. Well, let's decide if you want to keep it or not. We're going to keep it in this particular case. So now let's take on the persona of an end user and use a self-service experience to provision this cluster. So we're going to launch it. And as you can see here, it's giving me a few options. I'm going to give it a name. And we're going to give a cluster name. And we give an EKS Auto Demo 21, and we're going to deploy this in US West 1. We're going to start with Kubernetes 1.29 for now, and everything else is going to be default. Let's hit deploy, and in a few minutes, the cluster will get provisioned, and this is our cluster, EKS Auto Demo 21. And as you can see here, this cluster, it's inside Rafay, and as you can see here, is running Bottle Rocket. And if you go look at the labels, you can see that it's auto mode has automatically picked a C6A large, and you can see that Carpenter is also there in the on the cluster. Now, imagine as a user, you want to go and upgrade this cluster. Let's first attempt this with the web console, the Rafay console. So it was born with 1.29. Now let's upgrade it to 1.30. So all we had to do was go select the selector, and this changes the variables, and Rafay attempts to bring it to the desired state. In a few minutes, our cluster would be at the new version of Kubernetes, 1.30. And let's just kubectl to see if everything is all right. And all our pods are fine. Now, you can also upgrade the cluster to a new version using Rafay GitOps. So we're going to go to our Git repo where the entire template, etc., has been synchronized, and our environment is called env demo. And we're going to look inside the YAML, and if you notice, it says 1.30. So we're going to go and update that in Git, and we're going to watch our pipeline get triggered automatically. It's going to go there and make the change and do a pull request, and once that is merged, we're going to commit that directly in this case with a suitable message. It could be a pull request as well. And once that is done, the Rafay pipeline will detect the change instantly, and it'll attempt to bring it to the desired state. So this particular request, the job, let's go look at the details. And as you can see here, it says it's showing the message, upgrade the Kubernetes version to 1.31. And you'll see that our environment is now attempting to bring it to the desired state. And if you flip to the AWS console, you'll see that the cluster is now being updated to 1.31. In about 5-10 minutes, once the cluster upgrade is complete, you notice that the pipeline says everything is synchronized. And in this case, the entire upgrade took about 11 to 12 minutes. And our pipeline has the tracking information. And if the customer flips to the AWS console, you can see that it is now showing Kubernetes 1.31 as the version of the cluster. Well, that was it. Thank you very much.